Hello everyone, welcome to the Code Goat, and today we are going to learn about the decorators in Python. So most of the engineers, they do not use these decorators. It might be possible they don't know about it, or they think that implementing a decorators is a bit difficult. But let me tell you, these decorators are very simple. Once you've completed this video, you will become an expert of it. So stay with me till the end, and also there is a one assignment for you so that after working on that assignment, you will understand the real soul of these decorators, and you will try to use these decorators in your project everywhere. You will definitely try. So stay with me and let's start. So coming to this decorator from Python, the first things comes into our mind is what? What I mean is, what is decorator? So decorators are nothing but your Python program. Python program, or you can say method. What is method in Python? The one statement which we use after this def keyword. So this is our method. So these method can also be called as decorators. But there is a one slight difference in decorators method and your regular method. So let me tell you why. So coming to this, uh, let's assume, not assume, we are going to segregate these methods into two categories. So let's write this method one in which you write your logic. Let's say your sum logic, you have created a method for the sum, or you have created a method to calculate the average. These kind of program you mostly write in your Python program. And the second method in uh, which I want to teach you, that is supporting method. Supporting methods. But what are these supporting methods? So there is this one method in which you have write your logic, your sum, your average, and there is these supporting method. So how these supporting method can help your method in which you have wrote your logic. So let's say you have one method, this def, this sum, and here this a comma b, in which you are asking for the user is to print enter a, then print enter b, and then you are going to use this sum equals to a plus b, and then you are going to print sum calculated, and then you are going to return. So if I say there is one method which can remove these two lines and this line, so your code will become very short. All you have to do is write your logic and return the output. So it will become easier for you to write some method. And how I'm going to propose the solution using the supporting method. So once when the supporting method comes into the picture, you don't have to write these repetitive statements. So this is the soul of the decorator. The decorators are nothing but the supporting method. These supporting methods are there to reduce the work which you are going to do in your methods where you have to write your actual logic. So let me make it bit more clear. So let me clear it few more lines, and okay, here we have this which we have cleared, where we have supporting, we have this logic, we remove this supporting logic method, and how we are going to integrate this supporting method to the method in which you have wrote your logic by using this @rate method. So here we have this decorator one method which we have wrote. It will be used in your sum method like this. Then here is your statement and your decorator calling is finished. So in this way, you have wrote your logic sum without using any extra without using any extra work. You have just used the decorator and your work is done. So let me show you an example for it. So let's go to our code terminal, and here we have this very simple, okay, let me delete this, and very simple sample main. Okay, so it is the same method which I was trying to explain. So here I have this sum in which I wrote one print statement, entering calculate sum function. After this, I wrote my logic. After this, I wrote my print statement, and then again some more string to just for the debug process. And here it is the same method in which I just use the decorator, this log function call, and I don't have to write these entering calculate sum or exit calculate sum. All I have to do is to work on my logic. So in this way, I understood, okay, if I use these decorators, they are going to reduce my work. Then it's great. I'm going to use it every time. So let me just execute this particular sample main.py so that I can show you that these both things are returning the same. Okay, let me clear it. And after using this Python sample main.py, okay, coming to this code, it should write entering calculate sum, exit calculate sum, and between of it, there should be a result. Yes, entering calculate sum, exiting calculate sum, and between of it, I have my result. Coming to this decorator one, all I just did is I wrote my logic and just print the result. I don't uh, work to write some extra string in it. But at the output, what I see is, okay, entering calculate sum with def function, exiting calculate sum with def function, and the result. So here I can see that these decorators reduced my work, and also it provided me because these decorators should be generic, because we are going to use these decorators with all of our methods or with multiple methods. So these decorators should have some kind of a string in which you can identify, okay, this decorator worked on my this function and it executed the same thing which I wanted to execute. So yes, we achieved our functionality by using the decorators. So it is a very simple representation of using decorators. So just for your sake, here the decorator which I called this log function call, I wrote it into the decorators.py. Here I called the Python logging. So when it comes to the logging, I recommend you to use this logging method or logging library, which is very good. It provide you this info, warning, error, these all things it provide you, and you can use it in a very professional way. In place of using print statement, you should use logging. To know more about logging, let me know in the comments. So let's just focus on the decorators. Here we wrote one method, this log function call. This log function call we imported here, and this log function call we use it as decorator using the @ sign. Just don't get overwhelmed with all this, because we are going to understand the functionality by developing one decorator by yourself. So after that, you can understand this particular method more clearly. So we will come back to it once we will work on our own decorator. Okay. So let's understand the core methodology of decorators. So as I told you, these decorators is the combination of two methods. One method is your method in which you have write your logic, and the second method is the supporting one. So in the core methodology, we are going to create two methods. Let's say the first will be the username. Okay, so here we have the username where we have this name parameter, and it have a default value of ls, and what it do is it just return the name. And there is this second method, let's say greet name, and inside the greet name what we will do is we will call the function, and what we will do is return, or we can use the print statement. So the f with the high, and if I'm using the f string, it means I'm going to pass this func. Okay, so here we have this and this greet name, as we have created one method which can pass a function as a parameter. So what we are going to do is we will call the username, because username is a function which we are passing it here because we have wrote the functionality via the function, and it is the username. So that's it. So we have created our own decorator. Let me explain you how. So what I said earlier is it's the combination of two methods. So here we have created one method which call another method as its parameter. It's update the output of its value, and then it just return it, or you then it just return it. Here I just showed the print statement so I can show you the output, but what it usually do is it usually return after modifying the result. So this particular method is just returning the name, whatever the name I've passed here. If nothing is passed, then it will pass the ls. If I pass something, then it will pass that name. So on that name, what I did is I implemented a hi, or let's say hello. So let me show you the execution so that it will be more clear. So coming to this main.py, here we have this greet name. Okay, and we are going to execute our main.py. So it returned hello ls. Let's say I've passed my name. Okay, so let me pass my name Kshitij, and let's see what it will return. Hello Kshitij. And if I do here as hi, then Python main.py, it returned hi Kshitij. So just by using the decorators, I modified the output. I don't have to work on the same method all the time. I don't need to change its logic. Just by the supporting method, I updated the output. This is what I wanted to achieve. So it is the one functionality of decorator. Okay, and let's dig more into it so that we can implement an actual decorator, because it's a very basic, and it usually don't called as decorator, but it is the logic of decorator. Okay, so now we are going to create a blueprint for a decorator. So till now we just created one method, one supporting method, and it is not actual decorator, but it is the soul of decorator, where I've showed you that how that two functions can help each other. So coming to this blueprint, here we are going to develop our actual decorator. So let's create one method which is called this test decorator, and it will call the function inside of it, and inside of it we are going to create internal method. It will be the what I can say, this function wrapper. I will tell you about this, so just let me write it first. And inside this function wrapper, what I will do is print before function, and it will be the function which will execute, and after this print, and it will be after function, and once it is done, then return the function wrapper. Okay, this is the one thing which I create, and the second is function required function, let's say function for a function which required decorator. Okay, function which required decorator. Then let's say print uh, need a decorator, and as we have created the decorator, and what we are going to do is we are going to execute it. Let's execute this one just to show you, and then after this function required decorators. Okay, we will use the same, and we will use this test decorator, and this function required decorator, and then again we will call this method. So after this method, this is the one part, and again this is the another part in which I will use this test decorator. So let me comment this one. Oh, sorry, here. Okay, and okay. So just leave it till here, and let's understand it first. So inside this blueprint, here we created this. This is our method which need a decorator. It means this is a method in which we write the logic. And coming to this part, this test decorator, it is the actual decorator. So in the implementation of actual decorator, what we do is we usually create a method. Inside that method, we create another method. That internal method is the one which is going to provide the functionality of modification or functionality of reusability. So here we have created this decorator method, test decorator, and inside of this test decorator we created another internal method which is called as wrapper method. So internal method in decorator is called as wrapper method. This wrapper method is going to become the one which will provide the functionality. And after executing this particular functionality, what this decorator do is it will return it back. So when you call this test decorator on above this function which required decorator, what it do is in place of executing it directly, it will go inside the test decorator. It will execute this line. It will execute your particular method. And after executing your particular method, it will return the after statement. And after completing these all things, it become an object which will be returned after the execution. So it is not going to execute it two times. So it is going to execute this particular function required decorator only one time, and that one execution will happen inside the decorator. Okay, so let's test this one. I'm going to comment this part so that it will not interfere with us. And first, let's test without decorator. Okay, so what we will do is here and python main.py need a decorator, simple need a decorator. I got simple need a decorator. That is fine because I didn't do anything on it. So now let's comment this one and execute this one. So python main, okay, before function need a decorator and after a function. Okay, so we are close to achieving our decorator functionality. Sorry, this one. So we are close to achieving our decorator functionality. So let's try. Okay, we understood that how to call it. It is with the @. So what we will do is we will remove this one here. We will again uncomment it, and after this we will use this @test decorator. So till from our understanding, okay, it should This test decorator should take this function which is required decorator inside it as a function. It will it's a Python functionality. It's the Python will do it by itself. You don't have to write any other thing. All you have to do is just to understand that these decorators uh, in in uh, in any of the method when these decorators are used, these decorators will take those method as argument by themselves. You don't have to write anything. So here we have a needed decorator and it should run with these statement. So let's save it and execute it. And yes, it executed fine. So in the first part, we understood that it needs two methods. One is supporting, one is the logic one. And in the second part, when we write the test decorator or when we write the decorator, we need one wrapper function. With the wrapper function only, the decorator will work. Okay. So in this way, we understood the blueprint, we understood the core methodology, and I guess we covered this how to call a decorator too. So let's come to the nested decorator. So before going any further, let's test this one more thing. Okay, if what I do is I will comment this part. I will do this and I will do this. You can ask that if I have this function, why I need one inner wrapper function? What the output will come? Let's try. So if I execute this one, I will get this none type object is not callable. So why? As per the functionality of decorator, it should return something. It should return something. So when you are calling some other method as its uh, decorator, then it should return. And to return it, if you write return here, return this function, then what it will do is it will execute this before function call, but after this return statement, it will not execute the after function. But it is our requirement to write these lines too. So in place of doing these all things, what we did is we just put it inside the method, which is called this wrapper method, and the output of this method we returned. So in this way, we followed the functionality of decorator. It means we are calling a decorator. This decorator should return something. It cannot be none. So just to return it as complete logic, what I did is I created a one method, and inside that method, I did my operations. I wrote whatever I want, and I call this function wrapper here. So this function wrapper is returned and my execution completed successfully. So this is why we need a internal method while developing a decorator. So it's a must to have activity inside a decorator. Okay. So we understood we need two methods. Inside that two method, one method will have this internal method, and the second method in which you have write your logic, there the decorator will be called using @. Okay, so here we understood about decorators and how to call it. That there is this one thing which we need to know. Uh, when we use it like this, what it do is, okay, let me give you one more example by writing its name. So what I'm going to do is I will write the function name so that you can understand that how this decorator is going to change your methods property too and how to resolve it. So here we have this function which required decorator, and what I'll do is I will do the print statement for this function, and using its inbuilt method I will write its name. So it should return the name of its own method. So let's try it into our terminal. Let me clear it first and let's execute. So what it do is it returned this function wrapper. But what I did is I provided this internal name to the function which required decorator. So it changed its property, which is not correct. So for to not do these type of activity, when we write a decorator, we need to maintain the sanity of a method in which we are applying the decorator. So for that, what we do is we use the one library which is called from functools import wrapper, sorry, wraps. And how to use it, these wraps is when we write the internal method, we will again provide the wraps here as a decorator, and inside the decorator we will call the function. So okay, so this is the solution, and now let's test it. So now if I write this python main.py, okay, it returned me the exact name in which I have provided the dot name. Okay, so it worked fine. So inside the decorator, I use these wraps. These wraps will work in a way that the metadata of your method, of your Python method, will remain the same. It is not going to overwrite by the decorators method. Okay, so we understood one more thing for the decorator. So now we have this information. Let's comment it, and we will move it for the nested decorator. Okay, so how to create a nested decorator? In place of creating nested decorator, we can also see in this example only that we have already created a nested decorator. So if you see, we use this particular wraps method from functools as a decorator inside of our decorator's logic. So this is a decorator. This decorator is also calling one more decorator. So this is the definition of nested decorators. So these nested decorators you can create by your own as per your functionality. In place of wraps, you can use any other thing if you have in your mind. So let's move to the last part, multiple decorators. So can we use multiple decorator on a single method? And the answer is yes. So let's create one. So what we will do is we will create some fresh. Okay, uh, we will need this functools import wraps. So whatever we have learned, we will implement it here. And inside the wraps, let's create one method. Okay, let's keep it simple. We are not going to use the nested. Okay, now we will use it. So this uppercase, we will create one method, this uppercase decorator. It will convert your string into uppercase, and it will call the function inside of it. Inside the function, we will write this wrapper method. For this wrapper method, what we will do is we will take the result. We will take the result from this function, and from this function, and what we will do is return result dot upper. Okay, so it will make the uppercase, and what we need to do is we need to return our wrapper method. So fine, so it is the one, and what we are going to use is at the rate wraps with the function. Okay, so this is one decorator, and we are going to create one more decorator for the let's say some sign, exclamation decorator. So inside the exclamation decorator, we will call this method function, and again we will use that wraps for the function, and we will create the method, this wrapper method. Inside the wrapper method, what we will do is the result, we will use the same logic, result, result of the function, and return result, result plus exclamation. Okay, so I guess we just need to return the wrapper, and not this one. And what we will do is we will create one greet method. We will create the greet method, and inside the greet method, what we will do is we will return hello. What I'll do is I will just do the print of the greet method, so that whatever I got in a return, it will print it. So first what I'll do is I will just use the one decorator, which is called the uppercase decorator. And let's just think all of the other things are commented. Okay, everything is fine. And let's execute it. So coming to our terminal, clear all the garbage and execute. Okay, so what I did is I wrote it in, okay, let's keep this H is also small earlier. And well, I got all the letters in capital, but just for our sanity, I'm keeping this H as a small too. And inside the bash, again, if I execute it, then it will return the hello in caps. Let's provide one more decorator, which we have wrote here. And if I use this one, so it should provide me hello with the exclamation mark. And yes, we got it. So this is all the decorators. What we did is we just, these decorators are independent to each other, their output. So they are not going to clash. That's why we are able to use it. So we understood how to create the decorators, how to use the decorators, and what's the core logic to using these internal method while developing the decorators. Okay, so here we have these all things, and let's come to our assignment. So what assignment we have is, so we have this assignment, create a logger decorator which will capture all kind of error but do not show in console. But also, if I want to capture that error, it should be come into one text file so that I can debug it later. So let me show you the example first. Let's say I have this def and sum, create sum, and inside the sum I have this a equals to 10, sorry, this a equals to 10, b equals to 20, and what I'll do is I will do the return of this a plus b plus c. So here we have this a variable, this b variable, but we do not have the c variable. And if I do this create sum, let's execute it first so that you can understand it more clearly. Python main.py, I'll got the error, name c is not defined. And inside of my directory, I do not have any kind of out.txt. Why I'm telling you this out.txt? Because I already created one decorator. So let me import it from ultimate decorators, decorator, import capture error. Capture error, I guess this is the name which I wrote, and from this capture error I will ask it as decorator here, and now I will execute it. See, Currently, I do not have any out.txt, and let me execute it. So this Python main.py executed without showing any kind of error, and inside this out.txt, I got the complete error. So with this decorator, I created one very it is where it is. Let me close this one. So from this decorator, I created a very ultimate decorator. Why I'm calling this ultimate? Because when it comes to capturing log, this is the one error which you do not want to show to your client or do not want to show any of the business user. These kind of error you want it for yourself into your debug file. So this is the one which I got, and I want you to create a similar decorator like this. For an example, in this decorator.py, I use these logging methods, this func tool, everything. So these all things you will find inside the file which I will share you, a Git file, the complete code which you have seen till now. I will share it over the Git so that you can access it. But before accessing it, whatever the things I told you or I taught you, I want you to go and practice it by yourself. And I want you to create this one ultimate decorator so that you can understand that how much these decorators will be helpful. And if you get any error, if you get any issues, let me know in the comment section. I will definitely help you. And if you want me to tell you or describe you more something about anything, as you can see, this logging is a completely different module and it is required to understand in all the levels. So if you want me to tell about this logging thing, then definitely I will tell you, I will describe you, I will create another video for it. But first, I want you to go and learn by yourself. Then just ask me anything, whatever you want. I will be there for you. So keep practice, keep learning, and share and subscribe if you like this video. And thank you for and thank you for watching.